We're going to look at a few null measuring devices now. And again, a null measuring device is a setup or device that allows us to non-destructively measure the voltage or resistance of an unknown object. So voltmeters, ammeters, the resistance meters, ohm meter, you can pull out of a multimeter, change slightly the circuit setup and will then slightly change the measurement that you make. So you change something by measuring it. Well, in this case, we're basically setting up a balancing circuit so we can compare an unknown value to a known value. So for these types of null measurements to work, it's typically, think of it like a scale, right? Where standing on a bathroom scale, you measure your weight, but in olden times, right, we didn't have those types of scales, so you were measured against the balanced scales of justice. If you think of that, two pans on a pivot point, like a teeter-totter, a known mass was placed on one end, the unknown was on the other end, and you added and subtract known masses until it balanced. That is how measurements were taken in the past. That's how null measurement circuits typically work. You're comparing an unknown value to a known value. So a potentiometer measures potential, measures a potential difference. So it's similar to a voltmeter in that it measures voltages. Has a slightly different name though because it operates differently than a voltmeter does. So a potentiometer shown here is a power source with some internal resistance and a resistor value R that's variable. It's a variable resistor. So basically think of it like a giant dial. You can turn up or turn down the resistance of this resistor value. So this point of contact slides here is 0 resistance all the way up to maximum resistance value of R. Here's your unknown potential, unknown battery, and you have your galvanometer here set up to be a voltmeter. So you have a galvanometer in series with a resistance value, a large resistance value. So by changing this variable resistor, you can set it up so the current through the resistor is 0. So think about it this way. Current I is flowing through this circuit. Current I wants to flow down this circuit as well, right? It's being pushed by that battery. This battery is pushing back. How much current flows in this circuit depends on the resistance value of this lower circuit, which depends on how much of this resistor you include, right? The more of this resistor you include, the lower the current in this part of the circuit. The less of this resistor you include, the higher the current. So you basically balance it until no current flows in this part of the circuit, and you make note of what resistance value that is. So potential is I times R, right? Ohm's law. Find out what the resistance value Rx is when there's no current flowing in the galvanometer. Step 1. Step 2 is to replace this unknown potential with a known potential, with something that has a distinct known potential. And then redo the experiment. And you'll get a new resistance value out if the unknown, your known resistor value and your unknown resistor value are two different values, right? If by dumb luck, your known resistance value has the exact same potential as your unknown, then the resistance where the circuit balances, the resistance value here will be exactly the same. If the potential is higher for your known, then you need a bigger resistance value to balance the circuit. So what ends up happening is you get this equation below. Your unknown potential is equal to the known potential times the ratio of those resistance values. So again, you measure the resistance value of the variable resistor when you have your unknown EMF source in here. Find out what that resistance value is where there's no current flowing in the galvanometer. That circuit balances. Replace the unknown EMF source with a known EMF source, redo the experiment, find the resistance value that balances the circuit, no current going through the galvanometer for the known value, and then this equation gives you your value for your unknown resistor. It's kind of like a balancing act. It's kind of like the teeter-totter scales. If these are the same, then this ratio has to be equal to 1. The value R sub x and R sub s are equal to each other. If E sub x is bigger, then the resistance value is going to be bigger, and so on. So this is how a potentiometer works. It's basically a balancing circuit. And there's another balancing circuit for measuring resistances of objects called a Wheatstone bridge, which we'll look at in just a bit. And we do have a lab on the Wheatstone bridge as well. A Wheatstone bridge is a null measurement device designed to measure unknown resistance values by comparing them to known resistance values. Again, it's kind of like a scale, comparing an unknown to a known. So this is the Wheatstone bridge circuit. It's a little complex. You have an EMF source or a battery with some internal resistance. Current I0, I have drawn here, flows out. At this junction, current can either go through a variable resistor. The resistance with an arrow through it usually means a variable resistor. So I can change the resistance value of R3 easily. It's usually just a set of dials. It can either go through the top path or the bottom path. And then when it gets there, the current can either go down through the galvanometer or up through the galvanometer. And then through this resistor R2, through the unknown resistance value R sub x, out and back through the battery. So these resistors are examples of resistors that are not in series with one another, and they're not in parallel with one another. No resistor shown here is in series with any other resistor, and no resistor shown here is in parallel with any other resistor. So how a Wheatstone bridge circuit works is you place the unknown resistance value in one branch of the Wheatstone bridge. Then you adjust this variable resistor so no current goes through the galvanometer. When no current goes through the galvanometer, you've balanced the circuit. And the resulting unknown resistance value is equal to your known resistance value, R3, the one you tuned into, times the ratio of these two other resistances, which you would know. So again, finding an unknown resistance value, multiple of known resistance values times this R3 variable resistor, which you dial in so no current goes through the galvanometer. When no current goes through the galvanometer, the circuit is balanced and this ratio holds. If current goes through the galvanometer, this is not valid. So you basically, like scales, you wait until the scales balance and don't tip one way or the other. You balance the circuit here by adjusting R3 until current is not flowing up or down. Right? There'll be current flowing up or down. You don't want any current flowing through the galvanometer, which means all the current going through R3 goes through Rx. All the current that goes through R1 goes through R2. Therefore, this circuit must balance. So you can calculate the unknown circuit value using this ratio. And we'll be doing that in lab later on this semester.